So in the last video, we looked at differentiation by first principles, and I introduced this equation. In this video, I'm going to use this equation in order to solve some basic examples. So the first example we're going to look at is a relatively simple f of x equals 2x. So if we follow on from the equation, its derivative, its first derivative, f prime of x, should be equal to the limit as some small change in x approaches 0 of the function f of x plus delta x, which means everywhere we see an x, we need to replace it with an x plus delta x. Take away the original equation, all divided by the small change in x. So then if we expand the brackets out, we're left with the first derivative is equal to the limit as a small change in x approaches 0 of 2x plus 2 delta x minus 2x, all divided by the small change in x. So it's quite obvious to see in this straightforward example that we can very easily cancel out plus 2x and minus 2x. And then we're left with the first derivative of f of x is equal to the limit as some value approaches 0 of 2 delta x over delta x, which again very easily cancels down to being equal to 2. So therefore, the first derivative of our function 2x is equal to 2. So in the next example, we're going to look at f of x is equal to 5x squared. So how do we take the derivative? So the function's getting slightly more complicated, but still it's the exact same method. So the first derivative of f of x, or f prime of x, is equal to the limit as delta x approaches 0. And now everywhere we see x, we replace it with x plus dx. So we have 5x plus delta x squared. Subtract the original function, and as always, divide by the small change in x. So if we fully expand this out just to show exactly what's going on, we're left with the limit as delta x approaches 0 and 5 times So now if we expand that out, we are left with the limit as some small value of delta x approaches 0 of 5 times, and then when we expand this out, we have x squared plus 2 delta x times x plus delta x squared. And we still have minus the original function, and then divide by the small change in x. So if we keep going and expand out this bracket, we're left with the limit as some small change in x approaches 0 of 5x squared plus 10 delta x times x plus 5 delta x squared, and then we subtract, as always, the original function, divide by the small change in x. And then again, it's quite obvious to see that these things can cancel out. We have a plus 5x squared and a minus 5x squared. So then, just to show you every single step, we're left with the limit as some delta x approaches 0 of 10 times delta x plus 5 delta x squared divided by the delta x. So we're almost there now. So then we have the limit as delta x approaches 0. And what we can do now is factor out a delta x from each of these terms. So what we have is delta x. We have 10 times x plus 5 delta x divided by the original delta x. And clearly these two terms cancel out. So then we're left with the limit as delta x approaches 0 of 10x plus 5 delta x. Now we can finally apply our limits by simple substitution. So if we just apply delta x equals 0 to this equation, it will negate this term to 0. So then we're left with 10x. So to conclude, the first derivative of 5x squared is equal to 10x. So in the next video, we're going to look at a couple of more complicated examples.